I am Samboornalaxmi from EC department. In this video, we see about the circular convolution in a digital signal processing subject. So, first of all, what is mean by convolution? Convolution is one of the mathematical tool represent the signals. So, why we have to using the convolution in a mathematical, it acts as a mathematical tool. So, it is used for mainly transformation functions. What is meant by transformation functions? That transform converts the one domain to another domain of signal. One domain to another domain means time domain to frequency domain conversion. Why we have to go for time domain to frequency domain conversion? It's a task easy to handle it's one of the tasks. It's easy to handle in any manner. So, we have to go for transformation. Transformation mainly used for complex convolution and correlation process. Convolution, it's a mathematical convenient process. Complex convolution in a time domain is equal to the multiplication in frequency domain. Complex convolution is equal to the multiplication in a frequency domain. So, one of the mathematical convenience process for transform is the convolution. So, it's a need for transformation, mathematical convenience and need to extract the information. Convenience and duster. Extract the information. These are the need of transform method. Mathematical convenience and extract the information is the need for transform. So, complex convolution in a time domain is equal to the multiplication in a frequency domain. So, we have to select the convolution process in time domain. That convolution has the two types of convolution, linear convolution and circular convolution. Linear convolution and circular convolution. Here we take about the circular convolution. Today we see about only the circular convolution. Circular convolutions has the three types. First one is matrix method, then graphical method, then DFT method. Here we use only the graphical method. So, take on sequence, first sequence. Convolution is a formula for convolution is x3 of n is equal to summation of k equal to minus infinity to infinity x1 of n into x2 of minus n. That is sum of multiplication of first sequence and shifted version of time shifted version of second sequence. Time shifted version of second sequence. This is the convolution. Its convolution means sum of multiplication of first sequence and time shifted version of the second sequence. This is the formula for convolution. Then we have to see for the graphical method, concentric circle method. Another name of graphical method is concentric circle method. So, concentric circle method. Determine the circular convolution of two sequence. Take first sequence as example 1, 2, 3, 1. Then second sequence is 4, 3, 2, 2. So, we have to check the circular convolution for these two sequences. Each and every sequence is considered as the one signal. this is the representation of the signal. This first sequence is one representation for one signal, the second sequence also another one representation for another signal. So, we have to take the two sequence in equal length. In this circular convolution, we have to take the sequence in equal length. Then use the concentric circle method. Take first sequence in anti-clockwise rotation. So, 1, 2, 3, 1. This is represented as x1 of n. Then take second sequence in clockwise rotation. Why we have to go for this clockwise rotation means it's a time shifted version of second sequence. Already I told that one sequence is directly, another one sequence is a time shifted version of second sequence. So, we have to change the direction. This is x2 of minus n. This x2 of 0 minus k, so minus k. First 4, 3, 2, 2. 4, 3, 2, 2. Take a sequence as clockwise rotation, second sequence as a clockwise rotation. Then there are 4 steps in circular convolution. One is folding, another one is shifting, second one is shifting, third one is multiplication, fourth one is addition. There are 4 processes in circular convolution. Here we use the second method, folding and shifting, then multiplication and addition. So, a first one shifting is like x2 of minus k. First shifting is x2 of minus k. So, take then multiplication process. Multiplication, x1 of n here, x2 of n in outside. 1, 2, 3, 1. x2 of minus k. Here 4, 2, 2, 3. Then multiply these two values and multiply these two values and same as like this here. 4 into 1 x3 of 0 value. 4 into 1 plus 2 into 2 plus 3 into 2 plus 3 into 1. Four plus 4 plus 6 plus 3. 8, 14, 17. This is the first shifting answer, 17. Second, x3 of 1. The length of the sequence is 4. You have to move the shifting for 4 times. So, this is the first time. Second, x3 of 1. So, like this, second shifting. x2 of 1 minus k, outside x1 of n. 1, 2, 3, 1 and shifting like 4 here. The 4 is, first number of 4 is rotated into top position here, then 3, 2, 2. This first 4 number x2 of minus k, first shifting is, first number of first shifting is shifted into like this. So, 4, 3, 2, 2. Take a multiplication, 3 into 1 plus 4 into 2 plus 2 into 3 plus 2 into 1. So, like this we have 6, 4 2s are 8 plus 6 plus 2, 11, then 17, 17, 19. Then third shifting. Next first number of second sequence is shifted into here. 4, 3, 2, 2. This is x2 of 2 minus k. x1 of n is fixed 1. 1, 2, 3 and 1. Then x3 of 2, 2 into 1 plus 3 into 2 plus 4 into 3 plus 2 into 1. 2 plus 6 plus 12 plus 2. 8, 18, 20, 22. So, similarly, last shifting. We have the length of the sequence 4. So, last shifting is like same as four is shifted into final position here. x2 of 3 minus k. Then outside x1 of n is fixed 1. One, 2 and 3. The last multiplication, 2 into 1 plus 2 into 2 plus 3 into 3 plus 4 into 1. 4, 9, 4, 10, 19. That's it. So, in this procedure, we have to calculate the circular convolution. There are 4 steps. First one is folding, second is shifting, then multiplication and addition. What is the use of convolution? This is a mathematical tool which is used for the representation of the signal. Representation of the transform signal. The transform signal uses is, it is converted into one domain to another domain. This tool is used to handle the representation of the signal easiest manner. Okay. Two sequences is x3 of n, that is x3 of n is equal to x of k. First answer is 17, second 19. Then 22, then last answer is 19. It is also a length of the sequence equal length 4. First sequence's length is 4, second also 4, then here the answer is also a 4. Thank you.